Okay, good morning, South Carlton. Today we're going to do another online lesson by yours truly. It's been a while since we've done one of these, but understand that I am keeping track of your progress on Khan Academy and through all the activities I've been posting on Google Classroom. So please, if you're a little bit behind, take some time to go through those materials and make sure you're all caught up, okay? I'm still keeping track and tallies of who's being, following through all the material and who is not. And I can say that it can only help you in the end. It can only help you improve your grades when you do and put in some effort onto some of the work that is being posted online, okay? So please try to catch up. I know it's been a lot these couple of days, and we have no idea still when we'll return to class, but please take some time to learn some of these important concepts because math in grade 11 is still a mandatory subject, and a lot of the stuff that we learn here is a build-up for what you learn in grade 11, okay? So please be prepared for next year as well. This can only help you proceed forward, okay? All right, so for today's lesson, what we're going to be doing is that we're going to be learning about key features of a parabola, okay? And from last time that we did a video lesson, we talked about parabolas that can open either up or U-shaped like this, okay? So it's a right side up U or an upside down U, and we talked about what these were. These were equations, essentially, that you always had a second difference that is always constant. So if you need a brief refresher on that, be sure to watch the previous video on this channel, on this YouTube channel, okay? So last time we talked about whether if it was always going to be a straight line or U-shape. This time we're focusing directly on U-shaped curves, something that you should have learned from your Khan Academy videos, okay? And the things that we need to do get some of the vocabulary down is that we need to understand some of the words and definitions surrounding these particular shapes. And the words I would like for you to all remember are what we call zeros and vertex, okay? So the points that I've marked in blue here, we call them zeros because these are the same thing as our x-intercepts, okay? These are x-intercepts in the sense that these red lines, they cross our x-axis. That's why we call them zeros, because that is when our y value is 0, and that is when it touches this horizontal axis that we have here, okay? There's another point that I would like for you to remember, and that would be our vertex, okay? Let me use a different color. The vertex over here is also known as the highest or the lowest point on the graph, okay? Okay, and it's basically where the graph starts to curve back up or curve back down, okay? It is the peak or it's the point at which it turns, okay? So it is the turning point, the peak / turning point of this shape, okay? And we call this shape is called a parabola, by the way. Instead of me calling it an upside down U or just a standard U, I'm going to be reusing this word from now on, okay? But basically the vertex, this is an X, sorry. Let me write a little bit neater with this X, okay? This is when the U shape just starts to turn around, or if it's upside down, in this case, if you follow this U-shaped curve, it starts to turn around right about here, okay? This is the vertex right here, okay? And similarly, we have a 0 here as well, because that's where it touches the x-axis. And we have another 0 here as well, because it touches the x-axis, okay? So we always want to figure out these 3 points when it comes to any U-shaped curve called a parabola, okay? And I'm gonna tell you and teach you how to graph these particular shapes. So up until now, okay, we've been graphing straight lines. If I give you y equals 5x plus 3, you know now how to graph straight lines, right? You know that this is gonna have a slope of 5 and has a y-intercept at positive 3. It goes up, has a run of 1 and a rise of 5, right? So it goes 1 towards the right, and it goes 5 up every single time. This is what we worked on before March break. It's what we worked on the entire month before. But now we're going to be going on to curved lines. And we always have a parabola-shaped curve whenever we have something in brackets like this. We call them binomials, okay? So whenever you have something inside brackets multiplied by something else inside brackets, you're always going to get a U-shaped curve or an upside-down U-shaped curve that we call a parabola. All right, okay. Now the question is, how do we graph something like this? Well, first of all, what we need to do is find the zeros. And this is actually the easiest part, okay? To find the zeros of a parabola, okay, what you actually want to do is that you're going to look at this term, okay? And you're actually going to change the sign of it, okay? So right now this is a positive 1, right? The reverse of positive 1, if we were revert the sign, would be a negative 1, okay? And for this one, guess what the opposite of negative 3 would be? No, it would be a positive 3, okay? And that's essentially how you would do it. Now, there are some other things that we need to keep track of later on towards the next few lessons with respect to how to find zeros, but don't worry about that for now. All I need you to know is that for the zeros of any quadratic or parabola, all we gotta do is just flip the sign from a negative to a positive or positive to a negative. Quite easy. Okay, so that means on a graph, if I were to graph this, okay, let me actually draw it as neat as I can. Okay, that means I have a 0 at negative 1, okay, this is my negative 1, and another 0 at positive 3. Okay, now this is what it would look like in terms of a parabola. Now we can either go this way, sorry, that's a bad drawing. You can either go this way, okay, or it can go the other way. Could be upside down, okay? But we wouldn't really know it unless we find the vertex, okay? We need to find out where the vertex is because that tells us when do we stop going up and start going back down again, okay? We don't know where the vertex is, so we had to mathematically find it because we only have the zeros right now. We only know where the zeros, the place where the curves intersect the x-axis is. And the way that we find the vertex is we actually start to find the point directly in between our zeros, okay? So what we need to do is that we need to find the number that is directly in the middle of our two zeros, okay? It's very helpful to use our graph, but if you want to find the number in between two numbers, what you have to do is that you can do one of two things, okay? If I want to find the number in the middle of negative 1 and positive 3, what I can do is use visually my graph to figure out what that is. It looks like the middle of negative 1 and positive 3 is about right there. That's split in the middle between negative 1 and positive 3. And counting the squares, this looks like a positive 1 on the graph, okay? So we have a positive 1. So we can safely say that the middle value is positive 1. But let's say that we didn't know that, okay? We didn't have a graph to work with. How would we calculate algebraically? Well, we can do something called finding the average, right? If you find the average between two numbers, then that becomes the middle number. So if we want to find the middle value, okay, of any two numbers, what we can do is just add the two numbers together. Okay, we have a negative 1 and a positive 3, and divide them by 2. Okay, so negative 1 plus positive 3, okay, we get positive 2. Divide that by 2, we get positive 1. So it looks like that matches what we had here when we used the graph to solve for the middle number visually. Okay, now what we want to do with this middle value is that we want to substitute it as x. Okay, so our middle value is now positive 1. What we want to do is that we want to substitute that middle value in. So we plug that into our x. Okay, so I'm going to copy down this equation right here. So y is equal to x plus 1, x minus 3. And now what I'm going to do is I'm going to substitute x as 1 inside. Okay, so in other words, okay, my x is the same thing as positive 1, so I'm just going to write positive 1 inside, okay? Maybe get rid of the plus sign. Okay, so 1 plus 1 and 1 minus 3. all I did here was take this x, sorry, maybe a different color, take this x and take this x, because I know x is the same thing as positive 1, I just put that into that x instead, okay? Because we've already established that our x is positive 1, because it is our middle value, we can use it to find out what the vertex is. And we can actually use it to find out what our y value for the vertex is. Once we have that established, we can figure things out. 1 plus 1 is 2. 1 minus 3 is negative 2. And multiplying the two together, we get negative 4, okay? 2 times negative 2, that is negative 4. So now that we have these two things, we combine them to figure out what the vertex is, okay? These two, if we were to combine them, what we get is actually the vertex of our parabola. Our x value is going to be positive 1, our y value is going to be negative 4, okay? Therefore, our vertex will be at this point, wherever that is, okay? So at positive 1, negative 4, I'm going to have to mark the points first. So positive 1, and we move down to a negative 4. So positive 1, negative 4 will be all the way down here. So that becomes our vertex, okay? So I don't need to have this marker anymore. I don't need that point anymore. Let me redraw the axis real quickly. Okay, so we have both our zeros, and we have our vertex. Now all that's left is for me to draw a nice parabola that fits into it as much as I can. Okay, and this becomes my graph. All right, let's do another example. So what happens then if we were to have a 2 in front? Honestly, it doesn't really change much. We just follow the exact same steps as we did here. We'll do another example after this, just to wrap our heads around ourselves. Because it looks a little bit confusing at first, I understand. But again, we start with the first step, okay? First step is always to write down our zeros. Okay? And the way we find our zeros is that we look at the numbers inside the brackets and we flip the signs. This is a negative 1. We flip the sign, now it becomes a positive 1. Okay? This is a positive 2. I change the sign, and now it becomes a negative 2. Okay? Easy peasy. Again, this is the easiest part, so it shouldn't take too much trouble to just flip the signs around. Once we have our zeros, we can start drawing where the zeros are. Okay, so positive 1 on our x-axis, because again, these are our x-intercepts. Positive 1 would be right here. And negative 2 on our x-axis would be right here. Okay, the next step now is to find the middle value. Okay, find the middle. What is the middle in between value between positive 1 and negative 2? Well, on my graph, it looks like it's right here, maybe negative a half, I think. But let's actually do some algebra and confirm that using math, okay? Again, we're gonna find the average in between the two numbers. So what I'm gonna do is that I'm gonna add the two numbers together, okay? And I'm gonna divide it by the number of numbers, finding the average in between them, okay? So add them together and divide it by 2. So positive 1 added by negative 2, that's the same thing as 1 minus 2 over 2. 1 minus 2 is negative 1 over 2. That is negative a half, and therefore this middle value will be negative 1/2. Okay? All right. Now what do I do with this middle value? Well, I would actually set that as my x. Okay? So I set x as negative 1/2, and this gives me the y value to find my vertex. Okay? So again, what I do is I'm recopying the equation down that I had before. Maybe use a different color. Okay, I'm just recopying this whole equation down. Okay, so 2x minus 1x plus 2, and I'm just substituting my x's into these two x's. Okay, because I know that x is negative a half now. Okay, I can just simply write them in. Okay, negative 1/2 minus 1. And actually, let's stop using fractions because it's a little bit annoying. Maybe it's a little bit more helpful to write it in this form. Okay, negative 0.5 minus 1 is equal to negative 1.5, and this I believe is positive 1.5, okay, and multiply that by 2 in the end, okay. So now's the time where you would take a calculator and to actually figure out what all that multiplication is, okay. So what we want to do is figure out, using our handy calculator, what 2 times negative 1.5 times another 1.5, and that should give me, according to my calculator, negative 4.5. Don't forget to multiply by this extra 2 at the end, because that does change your answer by multiplying that value, okay? So that means we have our two coordinates, okay? So over here we have y is equal to 4.5 and x is equal to negative 1/2, okay? So I'm going to join them together, okay? And that creates the coordinate of my vertex, which is our x value is negative 1/2 and our y value is negative 4.5, okay? So this is our vertex, okay? Again, this x came from our middle value and the y came from the fact that when we plugged in our x as our middle value into our equation, we received a corresponding y value. Now, where do we figure out where the vertex is? Well, negative 1/2 is about right here, okay? And negative 4.5, I'm going to have to label some more points. So this is 2, this is 4, and this is going to be 6, I believe, okay? This is about 5, so I would say the point of our vertex is about right here. Negative 1/2 and negative 4.5, yep, I would say it would be about right here. That is, this point is our vertex right here, okay? So once we have our points, again, I'm going to draw a smooth U-shaped curve, goes up there, and there we go. The hallmark of the vertex is that it's when it begins to turn back upwards, okay? Right like this, okay? So you go down through your zeros. As soon as you reach the vertex, you go back upwards. All right. Last example, I'm going to have to move things around a little bit because I am running out of space. This one's a little bit interesting because there's a negative sign, but that's okay. It doesn't really change much. We just follow the same steps as always. We start with our zeros. So our zeros, we just take our values here and flip the signs. So instead of positive 2, it is negative 2. Instead of negative 4, it'll be positive 4. Easy peasy. We can draw a mock-up sketch right now, okay, of our zeros. So our zeros would be, one is over here at negative 2, and another one is at positive 4. That'll be right here. This is our x-intercepts, okay. Now we find the middle value. The middle value, if I look at this graph, right in the middle of these 2 points is, I would say, possibly positive 1. But I would check that, okay? I would check using algebra, okay? And the way I would check it once again is add the 2 numbers together, okay? And divide it by 2, okay? Negative 2 plus 4 over 2 is equal to 2 over 2, which is equal to 1. Therefore, it's right, okay? Looks to be correct. Our middle value is indeed positive 1. Again, we add the 2 zeros together and we divide them by 2. Okay, so this becomes negative 2 plus 4. Negative 2 plus 4 is equal to 2. Divide that by 2 is equal to 1. And now comes the next step in finding our vertex, okay? We substitute our x as positive 1, because that's what we got here, okay, into our original equation. I'm going to copy down our equation back down again, okay? And now what we do is just we substitute our x, because we know x is now positive 1. What we can do now is to actually just write that x as positive 1. Okay, because we substituted this in there. X is positive 1, so why don't we just write that in? Okay, now that we have this down, okay, we finish off the equation by calculating whatever y is equal to. So 1 plus 2 is equal to 3. 1 minus 4 is equal to negative 3. We multiply them together and we get 3 times negative 3 is negative 9. This is equal to positive 9. Okay, so we have our y value and we have our x value. Okay, so we combine them together to form our vertex. Okay, our vertex, we're going to have x coordinate of 1 and a y coordinate of 9. I don't think my graph actually goes that down. Let me extend this graph down a little bit more. That's not a very neat graph. Okay. 1, 2, 3. Okay, so according to this, our vertex will be at 1, 9. Okay. 1 is right here. Let's move 9 squares down. I think this will be it. Okay, so this is our vertex. 1, 9 vertex. Okay. And oh wait, it's actually positive 9. My apologies, I made a mistake here. So it actually goes to the positive side, because this is that would be negative 9, right? Well, made a oopsie doozy. It's alright. Let's move this a little bit down so I actually have more space. Made a mistake there. Okay. So I'm going to have to go up instead of down. Okay, so we're actually looking 9 squares up, because it's on the positive end. Okay. So let's count 9 squares up. 1, 2, 3, 1, 2, 3, 1, 2, 3. I think it would be around here, right? Is that 9 squares? 3, 3, 3. Yep, looks like it. So this is our vertex, okay? Didn't know which side was positive for a moment. 1, 9. And once again, we just draw a parabola that goes through our 2 zeros. Not this one, because this is just a marker I made, okay? And we would notice that this parabola actually points downwards, in the sense that it's an upside down U, and the reason why that is because of this negative sign over here. Okay, so whenever you have a negative sign in front of 2 brackets, okay, it always should have a shape like this. So whenever you have something like this, you notice that there's a positive number right in front here. Okay, a good way to check your answer is that, does your graph open up or down according to what your number in front here is? Because this number is positive, or there's no number. Okay, your graph should always look something like this. Okay, your graph should always look like a upright U. In other words, one that is not upside down. If you do have a number that is negative, okay, then you should be having the exact opposite happen. Okay, you should have a graph that actually opens downwards like this. Okay, and that is essentially what the negative sign does, and what the positive sign does to your graph. It flips it upside down. Okay, so that was a lot of information for you to internalize, but I would like for you all to rewatch the video and ask me any questions that you may have. And again, a lot of this stuff can be also be found on Khan Academy as well. We'll be reviewing it again and again until we finish all the content regarding parabolas before we move on to the last unit. Okay, I want to finish off quadratics, I think by the start of May, so we will do a big wrap up and review afterwards, so please make sure that you complete all the tasks by then. Okay, but again, if you're falling behind, let me know, and if you need any extra time or an extra assistant, I can schedule a Google meeting if you want to have a one-on-one tutoring or some kind of conversation about the work. But until then, I'll be seeing you guys. Okay? Good luck.